Welcome everybody. So nice to see you. Very nice that you could join us for this webinar in this times. I'm Andreas Sjåstad. I'm the convener of the Young Members Group within the FIB. I usually work in Norway for a contractor as a concrete technologist. But I early started getting interest in doing association work. And today we are so lucky to have the president of the FIB with us, Tore Olsen, and also Vlad Shekhovtsov. He's from Ukraine, and he's a member of the Young Members Group board and has done a very nice work on punching Shear, which we will hear about later today. After a brief introduction and some practical information, we will hear from Tore, and then we'll let Vlad have some minutes to talk about his work, and we'll also have Q&A, questions and answers. If you move your mouse up or down, you can see both the chat and something called Q&A. If you have questions about anything that's been said or about the FIB or the Young Members Group, please click on that button and just answer the question, and we'll answer it either right away, or we can gather them up and answer after each presenter has had their talk. Yes, so this first Young Member Group webinar series is about punching Shear, strength of reinforced concrete slabs. First, brief introduction about the Young Members Group. Most of you hopefully have heard about the Young Members Group within the FIB, but the FIB is an international association for structural concrete, which is made up by national concrete or structural engineering associations that come together and try to collaborate. And within these groups, so in these countries, they have Young Members Group to both train, but also to have a network and to teach each other so that we are better prepared for the future. So the International Young Members Group is trying to link and coordinate all the existing groups, Young Members Groups, and also help build new ones. So if you are coming from a country that does not have a Young Members Group, or at least, or even a concrete or structural engineering association, please contact us and we are able to help you eventually. Either via video conference, email. Try to keep it simple, but we have experience and we'll guide you through how to create such a group. And we try to, the International Young Members Group, try to organize meetings, events, symposiums, and conferences, and help young members to participate in both the planning and execution of these events. We also try to encourage and help people get into task groups or commissions within the FIB, or at least in their national members group, the National Concrete or Structural Engineering Association. And we want to just be, we want to represent a platform for dialogue, debate, and communication, for knowledge and network. That's some of the key points for the young people. And we have set an age limit, 35 or younger. If you are 37 and are struggling to find a network, please contact us. We are not that strict. But we want just to be sort of an easy way to get in touch with the professional association work. Yes. So remember, just ask questions in the Q&A. And we also, if in the chat, you can write which country you come from. That will also be very interesting. And now I will leave the word to the president of the International Federation for Structural Concrete, Tor Ole Olsen.
Thank you, Andreas. Can you hear me?
Yes, we can hear you.
Yes. Hello, everyone. And first of all, thank you for inviting me to this webinar. And I would very much like to take the opportunity to say a few words about FIB and why the YMG is so important for FIB. Let me see. FIB has an ongoing strategy process now, and the YMG is scoring very high in that process on what FIB shall focus on. And why is that? There are many reasons. Some of them I have listed here. And one is very obvious, that without recruitment, FIB will cease to exist. Manifold is important for FIB, as it is for every organization, but especially so for an organization full of experts. If you have specialized on, for example, Shear for decades, you will be clever on Shear, but you may not be a champion on evaluating what are the real challenges of the world, nor how to solve them. So using Shear as an example, it's just an example. We have many experts in FIB that can show us that this is a real issue. FIB enjoys the workshops of the national YMGs, the workshops to come. I realize you have big plans, and this is a benefit for FIB, obviously. FIB has, for many years now, given awards for achievement of young engineers, and that is inspiring for the entire FIB. The award, there are two. It's one for practical engineers and it's one for research. And the people that receives them are very proud, and we are proud of them. FIB member nations produce 86% of the world production of cement. This means that FIB matters. FIB can influence the world in many aspects. It could be environmental, competence, cost, and many others. And this is a responsibility that we feel and that we want to use properly. Andreas mentioned the committees and things within FIB. FIB has 2,400 functions in its committees and other things. And I dare say that every aspect of concrete is represented in one way or another, at one place or another. And how can you, or for that matter everyone, but you in this case, how can you benefit from the competence existing within FIB? FIB is discussing and hoping to launch an advisory council to enable retired active FIB members to still be active after retiring from professional work. Senior members can share their knowledge to help young professionals also to become active within FIB functions. FIB is launching a mentoring program. The FIB mentoring program brings together experienced professionals keen to share their knowledge and network, and young professionals starting their professional career and who are in need of advice from knowledgeable engineers. Mentoring is a cooperative partnership in which seasoned engineers pass on experience and knowledge to engineers with less practical and theoretical experience. Both parties stand to gain from this partnership. So this is a two-way thing. The young ones learn from the old ones to be more competent and active, and the old ones learn from the young ones to be less old. And finally, I have a few pictures. Headed Old Fool and Young Inexperience. The guy to the left is no fool. He invented the submerged floating tunnel bridge in 1888. The two to the right is my wife and me, realized by a young grandchild, and it gives a picture of what you can learn also from really young people. I learn a lot from my colleagues that are older than my grandson, but still I learn a lot. And sometimes they come and ask me to teach them something. And this, I feel, is the essence of what you are doing. And I support that very much. And I know that FIB does as well. So thank you.
Thank you, Torole. I'd like to introduce Vlad.
Yes. Hello, everybody. First of all, it's a little bit nervous to take a word after the president. I appreciate that this initiative gets a lot of attention and support of the big FIB association. It's very, very pleased for all of us, for all of young people. And the last your slide about the pictures, it's understandable that you're not so old. So we learn something to you and learn something from you. Okay, I'm trying to share my screen. Where is my presentation? Yes. Show the slideshow. Can you see my faces? Two of my faces, yes?
Yes, we can see both.
Okay. Can you see the mouse pointer? Or
yes, we can see the mouse pointer.
Okay,
yeah.
okay. So let's start. Hello, everybody. I'm really very pleased that the Young Members Group initiative attracts so many like-minded people from different countries, from far away countries. And today we are starting a series of workshops that will be held by members of our really friendly community. First of all, thanks again to FIB for the active support of your initiatives and for helping to organize this event in such a professional level, I think. This is the first series of our webinars that we are planned to be held at least 2 times a month. We try to take this step. The main idea of such actions is, I think, is to remove linguistic, geographical, I don't know, and other restrictions in the collaboration of young enthusiasts, of young professionals in the field of concrete, in the field of reinforced concrete. So this is what I'm thinking about. I take a deep breath and I think we can start. I'm trying to move my slide. So Firstly, let me introduce myself. Here is I see in the chat in the participants it's a lot of my friends, which we had a great opportunity to meet offline. But for new people, I think it is interesting to know something about speaker. My name is Vlad Shekhovtsov. I'm from sunny city on the Black Sea shore, city Odessa. It's situated in Ukraine, Europe. I was involving in FIB community 1.5 year ago in autumn of 2018. Now I'm a convener of Ukraine's Young Members Group. In Ukraine, we have FIB national group, and all our initiatives are holding with their fully support. It's so important. So having a FIB national group in your country is a really powerful support for youth movement. It's 100%. My occupation is I'm working as an associate professor at Odessa State Academy of Civil Engineering and Architecture. I'm studying future architects and civil engineers. It's not surprising that I'm work at the department of reinforced concrete and traffic structures. It compares associated with concrete, yes. In addition, I'm also involved in technical examination of the existing buildings, existing structures, and last years I'm also carrying out full-scale testings of real structures. Okay, before I finally move on, I want, like a first participant of this event, to tell you what are we discussing, what are these events are planned for. We are a huge community of young professionals, and we every day solve huge problems, gain new experience, knowledge, I don't know, and each of us undoubtedly has something to share with the same with the same crazy people like me. He will share, I think, his experience. It is a way to share his experience not only with the city, I don't know, region, country, but with the whole of the world. And I think it's so sprightly. However, I think it's the first time that we thinking about this organizing of these webinars. We think that my idea was that these webinars will be something different from the defense of diplomas or some reports at conferences. And I want them to go in such a more lighter form. It's not simply you're proving something or defending something. Like an example, we meet with our, for example, we meet with our friends for weekends, tell stories, sharing experience, a lot of fun, a lot of some laid back and friendly situation. So I try to set the tone of these webinars as a friendly communication. I want that the next webinars, next speakers will not afraid to present their experience, to sharing their some projects, some achievements in a friendly, lightly way. I don't know. I don't want to be that these webinars will be boring or real official, but after President speak, it's a little bit official. but we must break down the patterns, and we must lead these webinars, I think, in a new way, in a like light conversation on the professional sense. And the idea that they will not be so long, I wanted to have a time for 1 hours with including of questions and discussions. But we will see. I preparing for this seminar, for this webinar for 3 or 4 days, and I don't know how it was. So let's start. Let's not waste the time. So what is punching? What is punching shear? This is the first questions. I think that SpongeBob also interested in concrete, so I patted him. If Anders have time, he can check if he is already a FIB member. If no, you can mail to him. So what is punching? Yes, I like the sketches. This one is my favorite. It's so beautiful. So if we have flat slabs or footings, we are forcing with such effects which call punching. Why? Because in all these cases we are facing with significant local force on a real small area, like a column, for example, and this force tried to punch. You see a piece of concrete with a specific form from the whole slab body, like this picture, like this footings, this cone. You see, it's this effect due to the big value of shearing stresses, lateral forces, minimum values of bending moments. I find some pictures to fill this slide to explain what is punching mean. Actually, I'm really trying to find some 3D pictures or maybe short video, but only sketches and photos are presented in the internet for free downloading. Due to that, we will see some photos of punching through my presentation, my next slides. I used only sketch this, but they clearly understand the picture of this effect. I must admit that this effect is only relevant to slabs, footings, flat slabs without beams, flat slabs, footings, and pile gratings. It was firstly described in 1948. It was a long time ago, but we still haven't clearly understandable picture of modeling, how to model this physical process which occurs in concrete. For now, I know that we have at least 3 almost polar ways to predict shear forces, to predict punch and shear, to calculate punch and shear strength of the constructions of the plates, foot, and so on. And it was understandable that this effect must be studied and taken into account at design work. Yeah. Because even in modern codes, modern buildings, I know we faced, unfortunately, we faced with collapses due to the punching shear. If we neglected or unvalued such possible stretch conditions in the structures, we might have a problem. So let's see some pictures. These are famous pictures. The department store of South Korea. The problem was, like future investigation showed, that the problem was in design work and they put additional load on the roof slab. They put a huge amount of weight of conditional equipment, and they begin to move this equipment on the roof slab. So it caused the cracks and caused such brittle collapses, because the punching shear is the problem and is the way that we must predict, because it causes brittle collapse. We don't see the distribution of energy. We don't see characteristic cracks like in beams when they work on shear force, for example. So it was in 1995. The next, it is car park in the United Kingdom, 1997. This is an old building. It was built in 1965. And the problem was, in this case, problem was of maintaining this building, because there are problems with concrete, with repairing, with corrosion of reinforcement, corrosion of concrete, and defects of concrete, and also not enough reinforcement for these zones. So the next is from Russia. It is bowl of pool in Krasnodar, new sports center. The investigation, as I know from news, from papers, is that this was a problem with some design problems and some problems with materials. That not suitable type of concrete for such constructions, and when there was testing of this bowl by filling the water, the water flow down from cracks, so it is a problem with material, I think, caused such collapses. But collapses is punching shear, as you see on this picture. So I find something in the Twitter, maybe Spain, because this account was in Spanish language, and we see such situation under construction, that the slab collapses from punching shear on the columns, or rectangle columns. So we, and after these pictures, we fully understand that we can't neglect this situation, this possible stress condition which occurs in the body of a slab, in the body of such constructions. What I want to share with you, it is my experience. My webinar is the theme of sharing of my experience with you. Maybe you will have questions after I finished. This investigation not up to date. This investigation, this research is which I want to show you. It is a part of large research works that has been carried from 2008, and in which I directly performed experiments and adapted some numerical models. All researches were performed by me under supervision of Professor Klavanich. He's my supervisor of a thesis. And now I want to say a few words why it was necessary to lead such investigations that I want you to, in some short form to show you. Okay, let's begin. Till 2013, Ukraine used old codes, Soviet Union codes, to design concrete and reinforced concrete structures. It is from year 1987. The punching force, from the 2030, we go to the new one, and it holds Eurocode theory, Eurocode model of punching, but the experiments were a little bit earlier. So I want to tell you the story about what it was before. The punching force, according to these codes, was determined by finding the basis of some pyramid of forcing. It was believed that the edges of such pyramid are inclined at the angle of 45 degrees. Can you see this picture? In this case, only rectangular sections of the column were taken in account. The old norms take that you have to design with square or rectangular column, and you see such effect, such form of pyramid, and the calculation was based on this theory. The next development of such theory is go for Russian codes. It's for about control perimeter, but the theory of the pyramid of punching is still left. But it was clear at that times that such model need to be reviewed, and initial task for us was to determine exactly the shapes of punching pyramid, the angle of inclinations of the side, and the shapes of whole the pyramid. The shapes it puts into doubt at this time. And the second task was to identify the influence of cross section of a column, because we have only a rectangular square column. Let's see what they came. This is the formulas from old codes. This formula from Russian codes, they still used such theory. In Ukraine, we used Eurocode theory for the punching. As I said, till 2030, the current code approved, before the current code were approved, we used the prediction of punching force in such formula. This formula from old standards, the scientific idea was laid down, as I said, in the Soviet times. I want to say that now we use in Eurocode, we used that punching shear depends of compressive strength of concrete, but the previous theory was that the punching force is depends of tensile strength of concrete. You see this different concept of punching, and also we use other parameters that used in these formulas is mean perimeter of pyramid basis, which this value fully depends of shape of the punching pyramids. So the main goals was to define shapes of pyramids. with different types of cross section, with different types of stamps, and to upgrade the method of calculation, because we understand that it's not clearly defined the real situation. I need to remind you that at that time when I lead this experiment, we still use the old standard. So we try to get something new, but we must base on the standards that they were actually at the time. So we have we made the specimens. Here are some parameters. The reinforcement of the specimen was calculated in such a way that we have collapse from the punching, not from bending moment. And if you remember the last slide, the perimeter of the punching pyramid plays a key role in that formula. And here we see the various of these stamps. It is modeling a cross section of columns, but they all have equal perimeter. So the formula is not used cross section. We have different columns, but we have the same perimeter. Here you see physics-mechanical properties of specimen. The series of these experiments were making for 3 years, so we get a little bit different properties in concrete, unfortunately. It is C2025 and 25/30. Unfortunately, it's due to the properties of cement that produced in our country, produced by our plants, a little bit various year by year. So we have some difference in the properties, but we include these differences in our calculation and in our theory. So yes, here is a testing machine. It is a monster because it can give pressure for 1,000 tons. We used to such power of this testing machines when the atomic nuclear station anchors of plates which hold the reactor zone. They have anchors, and these anchors are testing on this machine, and the failure load was near 950 tons, if I don't mistake. So I saw that this machine was working in the best of its opportunity. Plates were supported by perimeter, so the upper part was stable and the pressure goes from the lower part. So we have upside down situation, but such frame we can see the surface, the bottom surface of a plate, and to fix cracks, to take from gauge values, and so this is available to perform this experiment. Here you see the stamps. The stamp were square, angle, form, and cross section. Next slides will use these words for defining the plates and specimens. So next slides will show crack patterns of slabs of all sides. upper and bottom surfaces. Here we presented patterns for 25, 50, 75, and 95% of failure load steps. You see the punching crack, the starting, the beginning. It is 95 before 95% before collapse. We see the forming of punching crack and became to collapse, starting to collapse with the pyramid cone. So the next is the second specimen, the same situation in the final stages. The next one. So here you see the photos. The photos of the pyramids by square stumps. The pyramid was used this in future investigation. It is the main goal to achieve the form of pyramids, to take its parameter and to apply it in formulas and in future investigation. And the main reason was to define the angles, the incline of its sides. Okay, so we have the next. It is surface. It is a crack pattern for angle. You see a little bit different pictures. You see here this punching crack, and yes, and the photos. You see the pyramid is differs from the square stump, and it has another form. So pattern for the cross section. You see it is interesting that upper surface we have almost circle here. This one, punching crack, is bottom surface, and the pictures of the pyramid after experiments, after punchings. As you can see, the difference is present, and there are no questions about the angle of 45 degrees. We need to investigate. We need to correct these formulas. You see, it is a sketch of from plan of these sites of quantity of sites of such pyramids, and you see that square is almost like in old theory, but when we talk about cross section, about angle, we have something different. And what we see if we use codes, old codes, some problems with bottom surfaces and the definition of perimeter bases. You see this picture, you see these pictures, and they are different. So we must improve this situation. And the next, it is yes. These pictures show that we have differences between codes calculation by formulas and experiment punching load. So the difference is from we have this 41%, 20, 22, but we have this minus almost 7%. It is not allowed to because the prediction the prediction is not true. It is dangerous prediction. So we have I think I lost one one slide. Square angle, I lost cross slide. But we have see the angles. The angles are different from 45 degrees, 45 degrees, and here you see. Here we can see actual angles of inclination of the side of the sides of the pyramid, and here's the column which we compares with Coates angle and real angle which we took from the experiments. This is a mean value of these angles. This also mean value. So we have improved, we used in those formulas, we try to use the real angles that we get from the experiment, and we compare with experimental data, experimental values of punching, and we see the difference. The difference is acceptable, it's normal. Like 10%, it's very good, I think so. But we understand. So before this slide, I want to say it that as you see, the arrangement of the results is rather good, as I said, but the way of breaking slabs and measuring angles is not an option. Sorry? Is everything okay? Yeah? I'm involved in my speech, so I can continue, yes?
Yes, you can continue.
Yeah.
Works very well, yeah.
Yeah, okay. I said that there's a breaking, every time breaking the slabs and measuring these angles. It's not the way, it's not engineering, it's not the normal way to further calculation and further researches. So the best way is to continue research, is to use modeling, is to use calculation, finite element calculation. So the second iteration is numerical investigation. We used non-linear model on reinforced concrete with crack, which was proposed by Professor Karpenko. It was based on his model of concrete. So here you can see stress function, vector function. You can see concrete surface, which holding in this model, possible cracking for a single structural element, and accounting for reinforcement. I know that this model is has alternative, because we used not reinforcement bars, but we used reinforcement ratio. But we can use all types in such a way. We can use in more easy way, I think so. We can use all types of reinforcement and all types of reinforced directions. So the model is allowed to do this. My supervisor, Professor Klovanich, created non-profit finite element software package for such numerical modeling, various to model various physical and mechanical processes occurring in concrete, because concrete is composite and rather hard material to get real behavior in the finite element in the modeling at all, not finite element in the like instrument. This complex uses volumetric 16 nodes or 8 nodes, sorry, 8 nodes physically non-linear finite element. Such element allows you to get fair and accurate results. So it is most importantly, and it is possible to refine the physical model of concrete with new data, with new and with new approaches. Yeah, I think this is my idea. With new approaches. First of all, we make a verification test. Yes, to fix and to check our model. We modeled a series of experiments that we took from the literature. It is funny, but my supervisor said that for verification test you must take only foreign experiments. Why? I said why? He said because they don't adjust the results. I hope it is true, and therefore all the numerical model for verifying tests was verified only on our authoritative results from the literature, and the model will work. So we try to make some numerical investigation. Here you see directly finite element models of the plates. I remember that is non-profit complex. This complex for not for engineering calculation. It is for research calculation. So it has a lot of opportunities to develop the model, to improve the model with new theories, with new experimental data. So it is really helpful, and we get a good result. Here you see some sections in the middle of the slab on which stress concentration, as you see, stress concentration, and you see the shape of the pyramid of punching. They're clearly visible. Yes. Also, all these results are well agreed with the experimental data in stress and strains that we measured under the experiments. And from this, I think it is about square, about angle. Yeah, you see the results about cross section. And after that, we can conclude that this model can be and should be used in calculation for punching and numerical studies of this real complex process as a punching shear. This is only part of results. I want to share experience. I want you to know that we hold such experience, that we investigate the form of pyramid, that we have some data, we have some calculations, some proofs about this situation, and it is a real good data for future work. The future work was that we continued experiment on punching with fiber reinforced concrete. We even performed some experiments. We used different types of metal fiber, but we have new standards. New standards were released. Then we have building crisis, and we have sad situations that we end up finding. And after releasing of new codes, we saw the need for further research. It's not so necessary, so we must stop. But big work was done. A lot of data were achieved, and if we have some opportunity, we try to use this data. No, not experimental data, but we use the modeling of punching, our model in our complex. Yeah, we have limitation that it is not sharing complex for one university. I don't know, for personal complex, I don't know. But the research data is really big. But I successfully defend my thesis and I stayed as a researcher. After that, I switched for some time for the masonry structures, but now I'm with you again in concrete community, and I think it's most all about. Instead of conclusion, thank you very much for your attention. And I try to discuss if there are any questions. I try to answer, and I hope to see again in the next webinar. Thank you very much. And my goal was to start this idea that is not afraid to sharing experience, even this experience is not the part of this experience is not necessary, but it is a part of huge investigation of concrete behavior that involves a lot of people, and sharing all this experience, all your achievements. Yes, I think it is a real goal. It is a real goal for our modern community, and to communicate each other. Only by these meetings, by our collaboration, we can be the world and be the FIP. I think so. So thank you very much. I breathed out. I hope you liked webinar and hear something interesting, and that is a good start for a big deal. Yes, yeah. Thank you very much, Andres.
Thank you, Vlad. It was very great to hear, and I know that we have some questions before we let you off the hook. If you go into the chat, you can prepare yourself.
Okay.
Because there were some generally about the young members group and the FIB, and I immediately answered them. But there were some specifically about your presentation.
Oh, yes, yeah. I'm very like Andre.
Yeah. Do you know some robust and stable numerical formulation capable of numerically simulating the fracture cone? Parentheses in where some cracks does not have continuity each to others in punching shear strength of reinforced concrete slabs. And he's interested. I'm not referring to compute the pick load. I'm interested to simulate numerical this cone fracture.
Okay, I read this equation, yeah. And I start to answer it. The first about flexural reinforcement. My first goal of the first stage of this experiment was to use such quantity of reinforcement that we have only punching shear. Then we we don't have collapses from the bending moment. So we calculated by by formulas, by the methods that we have for that time, and to achieve the quantity of reinforcement. I know the future investigation. I read a lot of in the Eurocodes, in the model codes about up-to-date thinking of punching. And as for me, I really like this theory of punching crack, yes, and angles which measures from slab deflections. And I understand this. It is the development of punching shear, understanding of its behavior. So it is about flexural reinforcement. It is also a fact. The punching shear is such situation which occur a lot of effects. So we have a lot of theories. Even the size of the aggregate is effect of the cone of punching shear. But the main reason, the first step of my experiment was to prove that there are no strict pyramids with 45 degrees incline of their sides. Yes. And about the next questions,
that the L-shaped parentheses angled column seems to increase the critical perimeter significantly. Do you think it is more efficient to punching resistance?
What is the question? I don't see. It is unlimited.
It's right beneath. It's in the answered ones, because I said we will answer this.
In the answered one. In the answer, yeah.
We'll take down those first.
Oh, okay.
Yeah.
That's right. Do you know? Robert stable numerical formulation. Sorry.
No, it's
sorry.
She had L-shaped question. L-shaped column. L-shaped column seems to increase the critical perimeter significantly.
Do you think it is more efficient for punching resistant? The main reason that we give that the shape is involved on the punching pyramid form, but if we compare with punching force of failure, it's not so necessary, so involving. So in the inner distribution of energy of stresses, it is we must check the cross section of column to get the right transangular reinforcement to take in the right way, because it depends the critical perimeter of the shape or of the shape of the cross section, and we see it in the pyramid, but the failure load is almost the same. It was the interesting conclusion. So we must check. We must understand about cross section, but it needs further investigation in such a way. And I think it is good to investigate it numerically with existing experimental data.
Yeah.
Yes.
Good. Then we move on to the next question, which is unanswered. It's in the open section of the questions and answers.
Okay.
First, thank you, Vlad. According to your experience working on the subject, is there any specific provisions to consider by using a code for calculation such as Eurocode?
Where is this question?
That's the first question in the open section. And now the questions are popping in.
By using code for calculation, it is interesting, but as I said at the beginning, we used at last for now we have at last three fundamental theory about punching shear behavior and punching shear calculation. We have theory from Soviet Union, from academics, Soviet academics. So this theory is used by in Russia, for example. It is a theory of control perimeter of shear of control perimeter with maximum shear stresses. But they used in their calculation, their theory goes, they used in their calculations compressive stretch of concrete. We have the Eurocode predictions. Eurocode predictions is also with control perimeter. We in Ukraine we must use such theory because we in our codes our punching shear paragraph is based on Eurocode position. Yes, so we use such theory, and we have another theory of model code of Professor Mutoni's theory that it was from punching crack. I don't know, punching crack theory, but they also use compressive stretch of concrete, not tensile strength like Soviet and Russian codes does. But the comparison of all these codes is acceptable, I think so. We must, unfortunately, not unfortunately, but we must use that the government said you need to use.
Yeah. And then there's a question about creating a Telegram channel for sharing experience throughout international FIB Young Members Group. I think this is from Russia, based on the name.
Yes,
we have certain groups for the Young Members Group to share. We have at least Facebook. We have the international, the website, FIB website, the FIB binder international.com, where there is a sort of closed group where you can ask questions, where you can upload files. And we have tried to create sort of platforms, but it seems difficult because not every country is using the same platform. And some platforms are illegal in some countries. So at least the FIB website is open for all, I guess, in all countries in Norway and the world. So if you send me an email, I'll type it in the chat again. We can try to find where you can get the latest information from the Young Members Group. And also they're able to share ideas and chat with or network with other people. Yeah. So it's now in the chat. So just send me an email and we'll take it from there. Yes, next question. How are you using this experience data in process of civil engineering?
It is it is a question also from Russian guys, because they are known that it is a problem to use experimental data to when we go to the production to the construction site and say, look, we have experiments, we have broke down a lot of plates. Here you are. You can make economical structure. You can use less concrete. And the designer look at me. Okay, when your calculation will be in codes, then I use your data. So, but in my situation, we have experimental slab in in a hotel when we try to use our real angle for real angles that we get from the experiments in the calculation for punching shear. They used formulas from codes which were actually for that time, but they used not 45 degrees, they used our data. And after the calculations, they make their reinforcements, they make their even shear reinforcement, and we get this project, this data before the drawings go to the construction site, and use it in numerical model to test all situations that the designer made. And after this investigation, we have correct a little bit the transverse reinforcement, and then they go to the construction site. So the involving in real life, there was some involving, not formally, like many of theses in our countries. I know about this, but this is not involved because I'm involved in some design processes, like design.
Yeah.
Thank you.
And if you don't feel that he has answered the way you want, just ask follow-up questions and we'll go through them now. The next one, did you also investigate the variation of flexural reinforcement ratio in your experimental campaign?
Where is it?
And it's two questions, or
about
to my knowledge, the flexural reinforcement ratio of the slab would also affect the inclination of the diagonal crack, hence the pyramid shape. Any comments on this?
So question. Where is this question? I don't see.
This is from Andri.
From Andri, yeah.
Yes.
I answered the first question because I think that you asked me the Andri question. I said that flexural reinforcement in my experiments, flexural reinforcement ratio was chosen to get punching shear collapse, not bending moment collapse. But I know that from numerical, for example, experiments, I know that this reinforcement ratio is involved on the situation of punching cracking, like a brittle collapse. So the main reason is to that if we have a lot of reinforcement, we don't get collapse from bending moment. And we collapse from punching. It is a bad way of reinforcing. Everybody knows that we must reinforce that the collapse wasn't in a brittle way. Yeah.
Andrei is the devil's advocate, so you will have trouble answering this. Regarding the numerical works, did you ever try to conduct a simple linear elastic analysis to investigate the distribution of shear forces length around the support? Let's just take that first.
Okay.
There's a comment after that.
When I make such experience, I don't have access to model code. Unfortunately, I even don't know, because a couple of years ago I know about the FAB, but we were not so involved. The last year when Ukraine is collaborate with Europe more collaboration with Europe. So that time we have collaboration so I have not access to the theory of model code.
Yeah.
But my investigation, it's there were not linear elastic analysis. It's were non-linear modeling with rather difficult mathematics in modeling. So we go to the iteration 3.
Yeah. But important to know that your data is and experiments are still valid, even though they are not done in the same way as some other countries make them.
Yeah. It's really valid, and we can
translate it into other standards by using the force area.
We can check it.
Example.
Not transfer, but I think we can check it. I think all experiments are valuable for any research. Next one.
Vlad, congratulations for your presentation. The column shape affects the stress concentration in concrete, but could you conclude if the collapse starts due to the compression stresses on struts, compression field, or on concrete tensile stress limit? Does the column shape affect the collapse method?
Thank you for the questions. I try to download it to answer.
It's right beneath Vlad.
Yeah. I found the question, but I need to understand it. With concrete, yes, effects.
And I would like to say that Toror Olsen is experienced in concrete for several years. And he probably has some good answers as well as you, Vlad. Even though you studied this, he has some other experience maybe from his experience creating all these oil platforms.
Experiments comparison with my theme, yeah.
Yeah, but he has a lot of experience and has talked to a lot of people, so he might have even questions and also some adding to the answers, maybe.
I understand the question from our colleague from Brazil, yeah.
Yeah,
so.
You can answer that first. Yeah.
About your questions, it is a good question. We have the same situation. The first cracks that appears were cracks from tension. We have deformation of the slab. We have flexural cracking. Then we achieve the reinforcement, and the reinforcement begin to
hold back.
Not hold back, but to tensile.
Take over.
Not to tensile, but to get stresses. Yeah. And other cracks were began to from the punching from the tangential forces, not bending moment, tangential forces, and this crack from tensile stresses went to the compressed zone, and when this crack reached the compressing zone, we have brittle collapse in 1 second. When the cracks
in 1 second
tensile zone achieve the compression zone. So here we have the result from experiments, from data from the experiments. But in numerical analysis, we modeling this effect when we have compressive strength more than compressive stresses, more than compressive strength of concrete. So we have such modeling such situation. But the reason is for tensile cracking, which occurs in the compressed zone, and then we have brittle crack.
Maybe it's best if Tor Ole, if you have any immediate comment, you can just reach right in.
Okay.
Otherwise, I would say that you can gather all your experiences and thoughts based on the questions and answers, and tell your experience on what is relevant by these questions.
Hello.
Hello, David.
I am David Fernandez. I'm the secretary of the FIB. I'm very happy to see the success of this webinar, and I hope that you have many like this, and we'll support you a lot. Congratulations to Vlad. Very nice presentation. I like it very much. And I just want to say that we are very happy to see so many countries, so many people, and I think we will support all these questions that you receive, Andreas, about how to connect with the national group. That we'll manage to work that, and we'll help you to do that. And just to be short, I just wanted to tell you that next Thursday, we have another webinar also. It's already announced that, of course, anybody can join if you want. And this is a little bit different, but also a free webinar from the FIB. And I will be happy to meet you again sometime soon.
Yeah, we will be.
That's very good. The 24th, it's open on the, I think it's on the FIB International website, but also the Facebook pages.
Yes.
And it will be very good for every young members to join and participate in that. I think there's already 350 people joining that webinar.
Yes.
So if we register today, there will be at least 400 by the evening. And that is very interesting because we can still answer or ask and answer questions and see what's going on in the FIB.
Yes, there will be short presentations, but different ones, like 4 presentations. Short presentations.
But you must register. You must register on this event from the FIB site. Website or from Facebook. I think
Corinne or Marie could post the registered link.
Yes, directly in the FIB website, you click there and you go to the register link. Or we can post it also in Facebook and again today, so it's fresh.
Andreas, you want some comments?
Yeah, of course.
Well, first of all, thank you very much, Vlad. Very interesting, and for your initiative.
Thank you.
And the subject you have chosen is not the easiest one. And as you showed many pictures in the beginning of structures that actually fails due to punching, is very, very important. Detailing the connection between columns and the slabs are extremely important, to put it mildly. And the nature of the problem is so complicated that I will not be able to say that this is how it is or this is how it is not.
Yes.
But the Model Code 2010 is available on the FIB webpage. I seem to remember that they are bulletins 64 or 65 or something. David can maybe correct me if I'm wrong.
About punching, The bulletins is about punching shear. I read
the bulletins about the Model Code 2010. the full code.
Yes, we have 4 bulletins, as a matter of fact, 54 and 55, no, 55 and 56, and 65 and 66 about the model code, yes.
And the 65 and 66, they're called preliminary, but I think they are the final ones.
Yes.
Yeah. Yes. So, and if you're a FIB member, I believe they are available for you for free. You can read them as a PDF. Isn't that right?
Yes, 55 and 56, they are free documents. 65 and 66, they are you can view it, but if you're a subscribing member, but we'll see how we make available for anybody who is interested.
Yeah. And as you may know, we are currently working with the model code 2020. So there are a lot of experts there working on also on punching Shear, and just showing the importance of it is valuable, Vlad, that you did. So thank you very much.
Thank you very much.
Good. Yeah. And before we move on, David, he's the secretary in the FIB, and Torole is the president of the FIB. And we would very much like your ideas to workshops or webinars, themes. Just send them to us, and we can try to set these up. Maybe not the webinars where you have to participate in a larger degree. It's a very high amount of participants. But for all the webinars where there's a few speakers and there's a lot of NTDs, these just throw them out to us, and we can try to arrange these webinars. For the workshops, that should be something that is initiated by either a group of people or some people that are really engaged in this, and we have to try to find the right people to participate in this workshop. Yeah. Next question, I think, was
about the book.
Yeah, the book. Yeah, what's the author? Great job. What was the concrete failure criterion in numerical simulation? Hashtag or the ultimate strain, stress, equivalent stress.
Okay, thank you. The book is really my book with my supervisor. It is for results of these experiments when they are finished funding, and we must achieve some collect some results and collect it in one book and share it to they are not to disappear these results. So it's very interesting because here as a book not so in the large way in the I forgot all words, but in that book we have a lot of pages and a lot of information about my experiments and the concrete modeling and model of the concrete and reinforced concrete and numerical investigation. It is interesting. They have algorithms and so on. And what about failure criteria? As I said, the failure criteria was when any elements achieve compressive strength of concrete. Yes, it is enough. The compressive weight of concrete which were get from the experiments and from the experiment, and this is what the failure criteria to achievement any element, but this element was in a compressive zone. It is understandable, and iteration was occurring.
There's a question from Zoran. What about punching with corners at shear walls?
It is another situation because our situation is rather different from common situation. Our situation is I think more suitable for footings maybe because we use small plates. We have not opportunity to use large plates to involve plates deflection in the spans, so we have some limits of spaces. So our situation is only what we can done in our laboratory. But corners and shear walls, it is another situation which need to investigate. And one of this picture of collapses was on the corner of the building.
Yeah. There's a question from Jose Felipe. How has the slab openings changed the modeling? And should the openings be avoided close to the column?
Close to the column. In this research, I didn't investigate the openings near columns, but it is a real problem in real life, in real design work. When I making project, I try to avoid such situation when we have openings near columns. I try to move it to the, for example, to the angle of the column, not for the face of the column, because in this region we have a huge and very valuable reinforcement. So, but architects want to hide these openings for communications between the columns to arrange this wall. So it is a real problem. But as my project, I always talked architects to move these openings from the center of the column. But I said about openings, huge openings which can get into reinforcement mesh. I not compare these openings.
Great. And there's a question from Fahed. When adding post-installed shear studs, are there any depth restrictions or other concerns about the type of grout to use, and a suggestion to reduce risk of debonding or pullouts of the studs? That's the latest question.
The transfer reinforcement in the punching shear zone, it is another way of investigation. We have the way to understand and to model the behavior of stresses of energy distribution in the body of construction. It is one way of investigation to predict shear power, shear stress, and other when we need transfer reinforcement in this zone. The main problem, it is anchorage of such reinforcement, and we use We use some we're using some types of reinforcement in our practice. They are making on the construction site by arranging reinforcement bars in one thing which we arrange at the column. The problem that workers don't like to arrange this. I forget the word.
Stirrups, maybe stirrups.
Stirrups, but I want
from the slab up into the column.
Yes, frame. We make reinforced frame with the transversal reinforcement. Welding frame.
Yeah, welding. Yeah.
Welding frame which that we situated on this zone in the different directions. But it is a problem for workers to adjust it. And I have a lot of words how you can design this, how you can make this.
Yeah.
It is a typical situation for this zone. We use such decision, but the problem that our spans is not more than 7 meters. So the punching force is not so high for this situation. 6-7 meters it is normal for 200 millimeters thickness, and it's necessary. Not huge punching reinforcement, not a lot of punching reinforcement. But if we have 9 meters of spans, it is a real problem, and we need to make serious calculation and make serious decision in practice.
Yeah. There's another question here. That's the last one so far. What about punching on footing?
Punching on footing, we have the same situation, even the same, not the same, but similar situation here. But the reason that the thickness of punching slab is rather high, is rather high, but the situation we have some situation with piles, but it is more easy to arrange transfer reinforcement in the thick plate in comparison with the thin plate. So in foundation we don't have such a problem, but we must to calculate, we must to understand that this situation could be in footings.
Yeah. Great. I think all the questions so far has been answered, and it's 10 minutes to we're actually finished. So before I wish you all farewell, do you have any words to say, David or Turula?
Yeah, maybe. You said great questions and chat, Andreas, and I agree. And this communication is, in addition to Vlad's interesting presentation, the questions and chat is a very important part. So thank you for that.
Yeah.
Yeah, it is a real communication. Yes. Communication, collaboration, and we met each other, we knew each other.
Yeah. And for the next event, which were first the FIB event, the 24th of June, and then the Young Members Group web seminar on the 9th of July. I think right after August, we'll try to arrange actually sort of meet and greet online where everybody can have their camera on, and we are able to present ourselves and meet each other halfway during the online session, which is much more not only for the theme of concrete or structural engineering, but just to meet each other and have a nice event. Yeah, but David?
Just one last thing.
Yep.
The Italian Young Members Group is also thinking on doing another event like this in mid-July, the 15th of July. So stay connected to the news on the website, because we will we'll say something about this.
Yeah, we'll definitely share it on the Facebook, but if by some reason you don't have Facebook or access to Facebook, they will probably be linked to on the FIB website. I think we've arranged some sort of event on the FIB international website that you can get access to those that information.
Yes.
Yeah. Good. Do you have any last words, Vlad?
Oh, I think we make a great start. I'm very like that you that we have such enthusiastic to perform this this action, and I'm appreciate that I can start it, and I want that this action will like we want at last two times a month. It is a new action, a new breath in our activity. Maybe we improve the collaboration. We will not so afraid of communication, of questions. I don't know. I want to that we will not feel the barriers, the borders. I don't know. We are a big community with sunny brains, and we want to. We everybody we have something to tell to anyone. It is a great opportunity, like I don't know, like TED conferences, but but time limits. I think we must 2 hours. It is for first time. It is normal, but I think we need to together in this time after work. I don't know. It is hard because we have a lot of time zones. But one hour it is a normal thing. I don't know. I think maybe we can more shortly, but inspiration is such inspirations that we want to collaborate, want to speak to each other for hours and hours. It is very interesting. It is my last word. For now, it is a really young members collaboration. The main idea and decision. Yes.
Yeah.
I'm stopped talking.
Thank you very much, Vlad. It was a great presentation. I think all were very pleased with hearing you. And as we learned both today and the last event, the Young Members Group webinar party, we at least need 2 hours, because we need to have some sort of practical information, general information, and then we can have some sort of specialized information. So we at least need 2 hours for each such a webinar session. But I would like to thank you all for participating. Thank you to Rola, David, Marie, Corinne for arranging this, Vlad for keeping such a great presentation. And don't hesitate to send us ideas or for workshops or webinars. We are very open to suggestions. And if you're suggesting one thing, we will most likely get it in the loop of the webinar series that we have. Yeah, so that's what I hope, because now we're in a different situation in the world. It will probably change forever. We used to only meet in conferences before. Right now, we're only meeting in webinars. In a couple of months or in a year, we will be doing 50-50, probably, where some people are able to travel and meet up in person, and some people are joining by webinar or by video conference. So very nice to have you all here. It was a very good experience. And remember, follow the Facebook page to get updates on the 24th of June, where there will be very good speakers, and also the 9th of July, and also the Italian group in the 15th of July. And I think Tor Ole now wants to say some final words. Yeah. Because he turned on his camera.
It's more polite to speak when people can see you. No, yeah. I just wanted to say thank you to all of you, Vlad and Andreas, and also the support from the FRB Secretariat. This is good. This is a good start for something great. So yeah. Thank you. Thank you.
Yeah. It's very good. And I should mention that for all you young people that are out there, I was lucky enough to be able to participate in the FIB Presidium, and I could see their strategy, and the number one thing they had on the list of 15 or 30 points, can't remember, depending on if you could put something together. The number one was young members. So we know as young people, the FIB wants us here. They're really putting in work to get us involved in this work. This is not something that we have to stride against. Maybe some places in the world, in our work or community, maybe we have to strive to participate in this work, but in the FIB, we are most certainly welcome. Just so you know that. And I think Tor Ole can agree.
Yes.
Yes. Yeah. But thank you all for participating, and please just send us questions, comments, what we should do, what we shouldn't do, ideas for workshops or webinars. There's no limits. Just send it and we can evaluate and take the conversation from there. And by that, I think we can end it by tonight, for tonight, 3 minutes before we officially end.
Officially end.
Yeah.
Very good.
Yes.
Thank you.
Thank you. Okay. Bye-bye.